Let us work on the jump next, because our character can move horizontally, but it cannot jump. For that, we are going to modify the way we calculate our velocity on every frame. We are going to make it a bit more complex, as we will add the ability to cancel the jump, as you will see in a few moments. But we are going to do the same as with the getDirection function. We are going to create a function to calculate the velocity, and we can call it calculate move velocity. So at the bottom of the script, let's add calculate move velocity. It's going to return a vector2, the type of our velocity, and for now we can return speed times direction. We'll have a few ways of handling this function. As you can see, we get an error because direction is not declared in the current scope. The current scope means the function. Each block that can fold, you can consider it a scope. When you create a variable like direction inside of a function, it is scoped or limited to that function. If you create it outside the function, let's do it like so. Variable direction is an empty vector2 like so. Then it will become available in all the functions in that file or in that class, because this file represents a class. The thing is, you don't want to have too many variables outside of functions, because having these values that people can modify, your teammates, and the code is a big source of bugs. It's hard to keep track of how these values get modified, and putting a value here allows you to modify the variable from outside the player script, from another script, a game script, a score script, or whatever. It's dangerous in that sense. That is why whenever we can, we will scope the variable, create them in a specific function. Now, for the move velocity, we are going to pass these values as parameters of the function. So we will need 4. Well, let's start with 3. We need a linear velocity. This is the name that Godot functions give to that velocity variable, if you want. In move and slide, the first parameter, velocity, is called linear velocity in the documentation, so we're going to use the same convention. I'm going to change the formatting for my parameters here. I'm going to align them vertically. So after each parameter, we want to put a comma to separate them, and we're going to add the speed as a vector2. We're going to pass every parameter explicitly. We're going to have the direction. It's going to be a vector2 as well. Let's order them like so. And for now, let's have just 3. This is a certain style of programming where we explicitly pass every parameter to the function to ensure that we know exactly which values the function is going to use to make its calculations. And there again, we do that to avoid creating bugs in our program. So we're going to calculate the new velocity. Let's create a new velocity variable in the function. And it's going to start from our linear velocity. So this function is going to take the initial velocity, make some calculations with the other parameters, and return a new value that we can then assign to our velocity or store or process however we want. So let's do it like so. We're going to take the original velocity. We're going to set velocity or new velocity.x. We're going to set it to speed.x times direction.x. And for the y component, it's going to be a bit different. So we're going to take the logic we had in the actor script, and we're going to remove it from that physics process here. We're going to take that line where we're adding the gravity, and we're going to put it in our calculate move velocity function. So new velocity dot y, we're going to add gravity times delta to it to make the character move down. We don't have access to the delta value here. We can either pass it to the function, or we can use a function called get physics process. Let's see, get physics process delta time. I'm searching in the docs to see the function name that I'm going to copy here. You can use F4 to bring that search help feature, and then you can look for delta time like that, delta underscore time, to find the get physics process delta time function. So I'm going to copy it, close the documentation, and paste it with Control V in my script, and add the parentheses to call the function. So this is going to return us the delta value that we had in physics process. That way we don't have to add another parameter to the function. So we add the gravity. Now we are going to add a condition if we jump. So if we are jumping, the y direction is going to be minus 1.0. So we can say if direction.y is equal to minus 1.0, we are going to override that velocity. We are going to make the character instantly jump. So velocity.y is going to be equal to speed.y times direction.y times that minus 1.0. So this is going to apply the player's speed. Allow me to go back to the player's scene, select it. Our y speed here, it's going to apply it going up and replace the velocity with that. So it will make our character jump. And for now, it should be good enough so that we can go back to the physics process function and use our calculate move velocity here. So velocity is equal to calculate move velocity. And we're going to pass the velocity, the first parameter of the function here, followed by the direction. So that will be the value of this variable up there, and the speed. Again, we're explicitly passing every parameter to the function to ensure that we call that a pure function in programming. It's a function that only takes parameters in, makes some calculations, and returns a new value. It does not directly modify a property of our character, which we also call mutating the values. We are grouping all these mutations, all these changes in the character's properties, in this case the velocity, in the physics process function, so that it's very easy to keep track of where we are modifying the player's or character's velocity. Okay, we can play the game now, and the character still does not jump. Now, there's one line I forgot that we have to change. We don't return speed times direction. Of course, we want to return our new velocity from our calculate move velocity function.